Alright, here we go. Let's try another fun one here. Sine to the 20th. There's nothing special about 20. This could be 200 or 500. Just sine to some really huge power. Let's see how you could reduce that. Again, this is one of those reduction formulas into an easier problem. Here we go. It starts off with being fearless. Okay, you must not be afraid. Make something your u. I'm going to call you sine. I'm going to call 19 of these sines u. The rest of it would be just one sign left along with the differential. Complete the dictionary, so du would be equal to 19 times sine 18x times the derivative sign, which would be cosine of x, times the differential of x dx. Going the opposite way on v, v would be equal to cosine of x. The derivative of cosine is of course negative sine. So I need a negative there. And that would tell me that this integral here, the integral of sine to the 20x dx is equal to vu, that would be negative cosine of x sine of 19 of x minus the integral of v du. So that would be minus, that would be positive 19. I've got a 18 sines and a cosine square dx. That's cosine gives me a cosine square. 18 of them, the 19 came out. That had a minus, and it's minus from that minus, so it'd be plus. That looks to be about right. And you say, whoa, now what? Famous identity here. Cosine squares can be exchanged for sine squares. So I have that the integral of sine of x to the 20th dx is equal to negative cosine of x sine to the 19th of x plus 19th integral of sine of 18x. Here we go with my exchange rate, 1 minus sine square x dx. That's the correct exchange rate for cosine square. That's one correct one. Clean it up a little bit, you get sine 20x dx minus cosine of x sine 19 of x plus 19 integral of sine of to the 18th x dx. I'm distributing that. I got a minus here. Whoa. I got a minus here, so that's going to give me minus. That's going to give me minus 19 sine 20x dx. You say, whoa, there's the boomerang effect again. I got the same thing that I started off with. Over here, 19 of them. I add positive 19 of them on both sides, and I get that 20 of these. 20 integrals of sine to the 20th x dx is equal to negative cosine of x sine of 19 of x plus 19 integrals of sine to the 18th x dx. Slap a 1 over 20 on both sides, and I get that the integral of sine of 20x dx, which is the one I sought from the beginning, is equal to negative 1 over 20th cosine of x sine of 19th of x plus 19 over 20 integral of sine of 18th of x dx. And that, my friends, is a reduction formula. You've got the original problem. You've figured it out into something that's slightly easier. You only have 18 of them. You could easily repeat the pattern just for fun. Try and see what the pattern would be. So long as you didn't simplify much stuff here, the pattern should be clear for you just from looking at this formula. I'll just do a little piece of the pattern here. What do you think it would be if it was sine of 18th of x dx? What do you think the pattern would be? Look what it was for 20. You see the 20 there. You see the 20 there. You see the 20 minus 1 there. You see the 20 minus 1 there. You see the 20 there. You see the 18th there. You got to repeat the same pattern. Now it's 18, so it would be negative 1 over 18 cosine of x sine, not 18, but 1 short of 18, 17x plus, again 1 short of the 18, that would be 17 over 18 integral of sine of, again this would be 2 short of the original one, 16x dx. That would be the pattern for sine of 18, and so on and so forth. Each one of these you could reduce, plug it back over there, and you'd be done in about 5 hours. Okay, famous reduction formulas by parts. Alright, peace. Maybe one more.